In level 3, we will be adding in phase shifts to our sine, cosine, and tangent graphs. This will be horizontal and vertical shifts, and they'll be really similar to other transformations we've done in the past. If you have a number that's added or subtracted on the inside by x, that's going to be a horizontal shift. And if you have a number added or subtracted on the outside, it's going to be a vertical shift. So x minus pi is going to be a horizontal shift, and that is going to shift just like before. When a number is subtracted, we would think that it would go in the in the negative direction, but it really goes in the positive direction. So this is going to shift to the right pi units. And then the plus 1 is going to shift up 1. Okay, so the amplitude of this graph we find the same way. We take the absolute value of the number in the very front, which we call a. So absolute value of -2 is 2. The period, since there's no coefficient in front of x, there's no period change, so the period is going to be 2 pi. The phase shift to the side, that's the side-to-side shift, is going to be pi units to the right. And the vertical shift is going to be up 1. When I graph this, I'm going to start with my vertical shift. It might be useful, we don't have an asymptote or anything like that, but it might be useful to pretend that you're moving your axis up 1. So I'm going to draw a dotted line here. It's not an asymptote, it's just a guide for me so I know where the center of my wave is going to be. It's moving up 1. So I think of it as like that's my new axis. And I'm going to label my my y-axis 1, 2, 3, my x, or -1, -2, -3. Then for my x-axis, I'm still going to go from -2 pi to +2 pi, since the period is still 2 pi. So here's -2 pi, pi. This is -pi over 2 and -3 pi over 2. Here's +pi over 2, pi, 3 pi over 2, and 2 pi. Okay, now this is a cosine graph. It's shifting up 1, and it's also shifting pi to the right. So I could think of like my starting place, like where my y-axis was, is shifting to the right pi. So this way over here. You could, if you want, draw another dotted line as like a guideline of where your y-axis is shifting to. So I'm going to draw a little dotted line here, and that's going to kind of be my new starting place. Like this is almost my new origin. It's not really, but that's like my new starting place for the graph. And then, so my first point from my new starting place would normally, since it has an amplitude of 2, with the cosine graph, normally I would start up 2 units, but since it's also being reflected, I'm going to start down below 2 units. So from that starting place, I'm going to go down here to -1. And then from there, I'm going to go up to that dotted line I drew, and then up 2 units at 2 pi. And then going to the left from my dotted line where I started, I would go back up to the dotted line from where I moved my x-axis to, and then up to positive 3, and then I go back down 2 units, back up, and then back up. And I draw my curve. So this cosine graph was shifted up 1. I moved the starting place pi units to the right. My amplitude became 2, and I also reflected it over the x-axis. In this next problem, we are transforming a tangent graph. A tangent graph doesn't really have amplitude, but since the number in front would be a 1, my first point, like when you have a 1, your point at pi over 4 is up 1. If that was a 2 in front, it would be up at 2, or a 3 in front would be up at 3. The period is pi over b. There's no number in front of x, so we don't have a b value, or the b value is 1. So the period is pi, which is the same as any normal tangent graph. And then we have a phase shift. It is shifting pi over 2, and since it's minus pi over 2, instead of going to the left, we go to the right. So pi over 2 to the right. And then there's also a vertical shift up 2. Okay, so to graph this, I like to start with my vertical shift. It's like, I think of it as I'm just moving my x-axis. So I'm going to make a little dotted line as a guide to me up here at 2. I'll label my y-axis. And since I didn't change the period, I'm going to still label my axis from negative 2 pi to 2 pi. Oops. Now I'm shifting this graph pi over 2 to the right. The distance from the origin to my first tick mark is pi over 2. So every one of these little spacings is a distance or an interval of pi over 2. So if I'm going to shift this graph pi over 2 to the right, I could start by moving my asymptote. So I have an asymptote in my normal tangent function at negative pi over 2. If I shift that over pi over 2, it's going to land on the origin. So I'm going to draw a dotted line, and this is an actual asymptote at or right on the y-axis. And then if I shift the one at pi over 2 over, it's going to end up at pi. So at pi, I'm going to draw a dotted line. My next one's going to be at 2 pi, and these are my asymptotes for my shifted graph. Now, for a tangent function, we have a point usually on the x-axis. Like we usually have one at the origin. Since it moved over, I'm going to have a point at pi over 2. But I don't want to put it there on the axis. I want to put it on my new axis. So it's going to be up here where I drew that dotted line. It's because I shifted up 2. And then halfway in between pi over 2 and pi at pi over 4, 3 pi over 4, I would have a point up 1 unit, and then halfway between 0 and pi over 2 at pi over 4, I would have a point that's down 1 unit, and then I draw the shape of my graph. And then I'm going to have that same graph in all of the in between each pair of asymptotes. And there we have it. This graph was shifted up 2 units, shifted pi over 2 to the right, and that's our new tangent graph.